I'm going to go ahead and hit start our recording. So then I'm going to share some resources. What I'm really looking for and what I would really love to see is somebody to model one of these in their classroom. And if there's some way that we can come in and capture that, whether you video yourself or I'll be happy to come in and, I mean, simple video with an iPad, anything like that. We'd like to see our teachers using it throughout the district so that we can encourage other people to attend the training and use the number strings and math talks. A lot of people are pretty nervous about opening those kits and beginning. So I have not had a chance to try one with a group of students yet from that kit. So if anybody wants to invite me out, I am open to that as well. So I'm going to go ahead and show this video from Christina Tonnevold. She's going to kind of describe what number strings are, and then we'll look at a teacher doing an example and talk about that as well.
Some people call them number talks, but showing your students a series of problems or visuals during math and then investigating the relationship between those problems is actually doing number strings. I'm Christina Tonnevold, the recovering traditionalist, and today we're going to take a look at what are number strings and how to make them in our quest to build our math minds so we can build the math minds of our kiddos. So to start off with, I want to explain just briefly what I mean by it's not a number talk, it's a number string. I have another video all about the difference between number talks and number strings, so we'll make sure to link that up down below. But really briefly, the original number talks were by Kathy Richardson and Ruth Parker, and they talked about it as a number talk is one problem or one visual, and then you talk about all the different ways that kids see that or think about it or solve the problem. A number string is typically a series, like a string of problems or visuals that are related in some ways. It's been kind of talked about as like people interchange those because there was a book called Number Talks that is a lot of they're really strings within that book. So I just want to clarify a little bit before we get started. And if you want to dive deeper into that, go check out the other video that I did about the difference between number talks and number strings. So a number string is a series of problems that are related in some way. Typically, there's what I like to call a helper problem. And I think that term originated from Kathy Fosno. Kathy Fosno that was the first place I ever learned about them. She called them mini lessons. But other people call them problem strings, number strings. But Kathy Fosno was where I originally learned about them in her mini lessons. And I'll link, again, I'll share some places that you can get more information about hers as well. So there is a helper problem that is typically something that your students know quickly. And then you show a problem that relates to that helper problem. And you discuss what kind of relationships kids are seeing. You don't want to point them out. You want to be asking questions and getting the kids to talk about what relationships they see, which is why I like to start with visual ones first, but depends upon your grade level. But most kids always need to start out with visuals. I'll show you some here in just a moment. So you do a helper problem and then kind of a harder problem, but it relates to the helper problem. And then you're going to give a similar kind of helper problem and then one that relates to that. So let's say your textbook, for anybody who does younger grades, our textbooks try to teach our students doubles plus 1 for addition. Use a double and you can chunk out the 1, right? So if it's 6 plus 7, just think about that as 6 plus 6 plus an extra 1. Well, a lot of kids don't see how 6 plus 7 relates to 6 plus 6, even though we do a couple lessons from the textbook. So you can create visuals that show like a 3 plus 3, that's a 6, and then a 3 plus 4. That's a 3 plus 3 plus 1, right? So you're helping them see the numbers within. You're helping them see the doubles. I could show a 6 plus 6 and then show 6 plus 7, but visually to help them see the 6 within the 7, right? So you're starting with a helper problem, the 6 plus 6, that's one that they should quickly know, and then you're showing the double plus 1 afterwards, okay? So that's the main idea, is you're doing a few of those where the helper problem, then the problem you're trying to help them see how it relates to another problem. And you keep doing a double and then a double plus 1, a double and then a double plus 1, a double and then a double plus 1. And then you might, depending upon your time frame and how often you do these, you might have just a couple problems that are doubles plus 1. So you might just show a couple of those without showing the helper problem first, okay? So that's kind of the typical makeup of number strings. So they can be with images, or they can be with abstract symbols. So here's some examples from a slide deck that we have created for our members of the Build Math Minds PD site. There are over 100 and some slides in this slide deck of number strings, but here is one that is showing a visual of a very popular multiplication strategy. So our textbooks will try to get kids to use, if you are doing 9 times something, just think about it as 10 times something and then subtract out the extra. But that's really hard for kids to visualize. So you build a string around it. And so I show 10 groups of 4, and then I show 9 groups of 4, and we have a discussion about what's the same, what's different, how could I write this, what kind of multiplication problem are we showing in each of these, how could we write this with symbols. And then I'm going to show the next one here that is 10 groups of 6, and then 9 groups of 6. And then I might show another one of 10 groups of 3, and then 9 groups of 3. And then to kind of finish this string, I might show one without a helper problem, and I'll just put up 9 groups of 5, and I'll ask them, so based upon what we've talked about in this string, what's a way that we could think about this problem to help us out? If we don't instantly know 9 groups of 5, instead of counting all those dots, how could I think about this problem, right? And not everybody in the class is going to come up with it, but that's why we need to do strings a lot. We need to do these visuals a lot. Get kids to notice relationships a lot. They have to do it over and over and over again, and we want them to be looking for relationships. It doesn't just happen from one lesson in what we're trying to do with fact fluency to help our kids learn doubles and doubles plus 1 for addition, or make 10, or using strategies like this for multiplication, where if you have 9 groups, you could think about 10 groups. It comes from doing a lot of these over and over and over again. And again, it doesn't have to be visual. Here's an example where we kind of write it out in words. I'm still using the groups of to remind them that multiplication means groups of, that I want to elicit that visual that we have used before, that 10 groups of 6 and then 9 groups of 6. And then you can even move into strings that are very abstract, like this one, 10 groups of 5, then 9, I'm still using the groups of 10 times 5, and then just show 9 times 5, and then 10 times 8, and then 9 times 8, and you keep going. And again, you might show some without helper problems, but that's up to you. Maybe your students need those helper problems more, and you're going to do some more and more number strings, and then you're going to try some without the helper problems, but you do want to have at least a couple helper problems before you just jump into just tell me how you think about it. All right, so number strings are just a great 5 or 10-minute activity that you can do with your students to help them look for relationships between different visuals or problems. This is one of the best ways you can help your students discover strategies for addition, subtraction, multiplication, and division without you needing to directly teach those strategies. Kids will naturally start to develop them by using those visuals and seeing relationships within problems. Now, you can find pre-made strings just by Googling, but I want to encourage you to try to make your own. I make mine just with shapes in a slide. And I want you to make it your own because it depends upon what your students are needing and the connections and relationships that you want to help them build. Now, as I said, for those of you who are members of the Build Math Minds PD site, we do have a more in-depth video for you about number strings and a bunch of pre-made slides for addition, subtraction, multiplication, division, even fractions. But remember, I want you to kind of create your own. We're just giving you a baseline. So all of those slides that we have for our members are totally editable, and you can use them as we have them, but you can also modify them to be what your students are needing at the time. So I hope that this helped you build your math mind so you can build the math minds of your students. Have a great day.
All right, so I'm going to give you a minute just to kind of process and digest that, and then we're going to watch a number string. What I have noticed in kind of researching and looking around at different math, like whether that's Kathy Richardson or this Build Math Minds, which is this lady's website. What I have noticed is that no two people do it the same way. However, they are very similar in that the way Hand in Mind presents this to us is that there's the helper, the helper, then there's the problem, and then there's what she calls the clunker. So I'm going to give you a minute just to process that, and then we'll move on. Also drop in the chat whatever questions you may have. I've had a lingering cold for like 3 weeks now, and it's clearing up, but it just, now everything's making me cough. I don't think the change in the weather helps either.
Some people call them number talks, but
No, we don't want to hear that again. So, all right. So this is going to be an example of a number string with multiplication. I believe most of us in here are elementary, so most of us are working on probably single digit addition, subtraction, maybe double digit with your students. But I kind of want you to notice how she progresses through this. This was one of the best examples that I could find. So her helper is going to be 2 times 7. You'll see her present that. And then the students are kind of going to base their thinking for the next problems off of what they did with 2 times 7. And notice how she also honors everyone's strategy as well.
Okay, we're going to get our answer out of the way. Let's put all the answers we think could go here. In the back, will you tell me your name?
Paige.
Paige, what's your answer to 2 times 7?
14.
She says 14. Can you show me if that was your answer as well? You show me too. Right down here against your chest. Okay. Any other answers we want to add here? Or do we feel confident about this answer? Okay, so now I need to know how you see it. Paige, would you like to share your strategy first?
Yeah.
Are you P-A-I-G-E?
Yeah.
Okay, so this is Paige's strategy. Paige, how did you see it?
I knew that that 2 7s equals 14
How did you know that?
because 7 plus 7 equals 14.
So you saw it in your mind as 7 plus 7 is 14. How many of you also thought of 7 plus 7 is 14? Okay, thank you, Paige. Who saw it in a different way? What's your name, sir?
Nick
Nick.
or
N-I-C-K?
Nick.
Nick, will you spell it for me, please?
N-I-C-K.
Okay, Nick.
That's Nick.
How did you see it, Nick?
Well, I saw the answer of 14 by doing a count by 7, 14.
So you skip counted? Okay. So you saw like 7, 14, kind of like that because you know how to count by 7s? How many of you also use that count by 7 strategy? Okay. You saw it. What's your name?
Natalie?
Okay, so this is the Natalie strategy. Natalie, how did you see it?
Well, in my mind, I knew that there were 2 7s, and then I skip counted, and then I knew that there was 14.
So you also skip counted the same way as Nick did? that right? Okay. So Natalie also saw the 7 through 14. Okay. Again, we saw that same strategy. Who has a different strategy? Something we haven't seen yet. Tell me your name.
Jennifer.
Jennifer. Jennifer. Okay. Jennifer, how did you see it?
Well, I used the touch points.
The touch points. Can you tell me about that?
Yeah.
Would it help to come up and touch it as you explain it?
Yeah.
Will you come do that for me, Jennifer?
So you go like 1, 2, 3, 4.
Okay, so you said 1, 2, 3, 4, 5, 6. Is that getting you the answer that you wanted?
No.
Okay. Did you want to share a different strategy?
Yeah.
Okay.
Okay, so I know that 7 plus 7 is 14.
So you did 7 plus 7 as well? Great job, Jennifer. Thank you. Will you have a seat? How many of you also saw Jennifer's way? Okay, I think we're ready for another challenge. Oh, don't worry. We've got more coming. Here we go. Are you ready?
Yes.
Okay.
Yes.
Get your fist ready. Tell me you're thinking. Okay. And again, thinking. Thank you so much for not talking. You were doing great. 4 times 7. Okay, volunteer to share the answer to start with. What's your name, buddy?
Michael.
Michael, what do you think the answer is?
28.
Michael says his answer is 28. How many of you agree? Okay. Are there any other answers we'd like to add to this list?
Oh, you don't have the answer, but I have
Do you have an answer to add to the list? What's your name, sir?
Stuart.
Stuart. Stuart, what answer would you like to add?
Oh, no, I answered strategy.
Okay. Stuart, you want to give us your strategy? Will you first tell me how you spell your name because that's important?
S-T-U-A-R-T. The
Okay.
S looks like a 6.
I know. I apologize. Stuart, how did you solve it?
Well, I added two 7s, which made 14.
So you
And
started
then
by adding 7 plus 7?
Yeah.
Okay.
And then I added another 7, another 7 plus 7.
Oh, so you did a separate 7 plus 7?
Yeah. And
Like-
then I added.
Did that also equal 14?
Yeah.
Okay.
And then I added 14 and 14 altogether.
And what was your final answer when you added the 14 plus the 14?
28.
Why did you add those 7s?
Because I didn't because I couldn't count by 7s 4 times, so I could count by 2. I can add 2 7s.
Okay.
So it's sad, so.
Why did you add 4 7s?
Because there's 4 right there, so 4 times 7
Means 4 7s. Good job, Stuart. Thank you. All right. Who's got another strategy for us? All right. Your name?
Rocco.
Will you spell that for me?
R-O-C-C-O.
All right, Rocco. How did you think about it? Did you also get 28?
Yeah.
Okay. How did you solve it?
Well, I saw that 4 times 7, it means like 7 full times.
Okay.
So I put 2 of them together, which equaled 14.
Uh-huh.
And then I did another 2 7s, which would equal 14. So I added the 2 14s and it equaled 28.
So you saw it the same way that Stuart saw it? Okay. Who's got a different strategy? Something we haven't seen yet. Oh, let's see. Spell your name for me again.
Logan.
Oh, Logan, that's right. Okay, Logan, how did you see it?
I saw it as an array.
As an array. Tell me more about that.
It's when there's rows
Mm-hmm.
and that one of the numbers are, so I did 7 in a row.
In the row going this way. Okay, so you did 7 across the top like that. Okay.
And then I did another 7 like a row.
Okay.
And then I saw that 7 plus 7 equals 14. So I did it again and then it was 28.
How'd you get to 28?
I got 28.
Okay, I'm going to jump ahead a little bit so we're not watching kids. So they do repeat a lot of the strategies, but I'm going to move on to the end here when she introduces the last problem. And I think everybody else kind of has a little bit of different strategy. She's going to introduce 3 times 7, and some kids base their answer off what they got for 4 times 7, and some base that answer off of what they got for 3 times 7 or 2 times 7.
Rose going down this way in 3 7s.
So you saw 7s going this way?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, like that?
Yeah.
Okay, so if that's a 7, okay.
I saw 3 of them and
You saw 3 just like that?
I knew 7 plus 7 was 14, but I didn't know what another 7 was, so I counted it in my head and it was 21.
So you knew 7 plus 7 was 14 in your brain, you knew that?
Yes.
Okay, that was called a known fact for you?
Yeah.
Okay. And then you weren't sure what 1 more 7 was, so how did you go about figuring that out?
I counted the 1 more 7 with the 14.
Did you count on, like you put 7 here and then you said 8, 9, 10? Like that?
No, I counted from the 14 and I went 15, 16, 17, 18, 19, 20. 21.
Okay. So then from 14 you counted on 7, so that would look like this. 14, 15, 16, 17, 18, 19, 20, 21?
Yeah.
Okay. Okay. How else did we see it? How did you see it?
Well, do you see the 28 up there?
Do I see? Are we talking about this 28?
No, you'll see. I minus 7 from it. That's how I got 21.
Okay, so you
28 minus
looked at a
7.
previous problem and that helped you?
Yeah,
Yeah.
So 28 minus 7 equals 21.
28 minus 7 equals 21. Let's take a minute and just think about that. Why did he take 7 away from this 28? What can we see here? Think it over. Have an elbow partner conversation. Why did he take 7 away? I want to come back to the owner of this thinking.
Me.
Right. Tell me, why did you take 7 away?
Well, it's because I thought it would be good to do a minus problem, so.
So you were stretching yourself to think of a new strategy. How did you know to take 7 away?
Well, I knew that 28 minus 7 equaled 21, so I just did it.
You did the math excellently, but I'm wondering, how did you know to take 7 away? You knew how to take 7 away, but how did you know to look at this problem and take 7 away when you were looking at this problem?
I don't know, I just got in my head.
Okay, maybe we can help him think about his thinking. Does anybody have a prediction as to why he did what he did? Can you tell your thinking?
Because it was a 4, because it was a 4 times 7 instead of a 3 times 7, so he took away 1 7.
So this is 4 groups of 7, and this is, what would this be then? 3 groups of 7. So did you just have to take one of those 7s away?
Yeah.
A very interesting strategy. Who tried that?
Me.
Okay, before we go on, I forgot. We have 2 answers on our list, and I want to come back to you, Grace. Do you have any thoughts about your answer? Do you want to keep it? Do you want to change it?
Change it.
What do you think your answer would be now?
Probably 21.
Okay. How do you
Okay, I'm just going to stop there. Either unmute or drop some of your things. I've watched this video about 3 times, so I know what I notice and wonder. What are some of the things that you notice? Oops, I hit escape over here. Okay, what are some of the things that you notice in this video that you may what stood out to you? Something you have not seen before. Yeah, she was using the strategies or their prior knowledge. Um, did she have a scripted way of teaching this in front of her? What did she kind of base what she was going to be talking about and teaching about on? Yeah, she was using the kids' prior knowledge of adding on. So maybe she went in that day and nobody knew 2 times 7. That's where you got to do a little bit of teaching with the 2 times 7. But when she got down to that 3 times 7, she started talking about, well, okay, I thought the kid was really cute. Well, I just took one away. I thought it'd be good to do some subtraction. He's kind of cute. But notice that when she was talking about the 3 times 7 in relationship to the 4 times 7, she was like, well, yeah, notice because this is 4 groups of 7, we had to take a group away. So that was an opportunity for her to kind of teach based on what the students were saying and listening to them so that you're not teaching a strategy that one that's too hard for them, or number 2, a strategy that they may already know. And if you notice, I'm going to show you the example stuff from the Hand to Mind kit. If you notice in the Hand to Mind kit here, this is a math talk. So math talks are your chance to evaluate. So number strings are what we're going to do first. What they recommend is 3. Now I know ours is our stuff, and I'll share these with you as well. But our time in CCR is very different. And I know sometimes really all you have is about 3 minutes, 15 minutes to get to IEP goals. You have 30 minutes of time in there. And so I don't want you to think that you have to do this every day, but do build in some regular practice with it. So after you do about 3 or 4 number strings, that's when you want to go into that book and open up to that number talk to see if kids are using the strategies. So here she did, they do have the big Rec and Recs. If they are part of your kit, they're in there. And there's any other manipulatives you might need. There's a big one you can put on the board. So what they might do with this 2-row one is she put 9 on the top and 1 on the bottom. And then how many beats? Well, the kids are all going to say 10. And then you start talking about, well, how did you know? And the kids said, well, I know 9 are on the top because there's 1 over here. Or some may move this one away. Or you might need to say, what if I slide this over here? If I take 1 away from the bottom and I add 1 to the top, the kids probably already know that there's 10 beads on the top of that Rec and Rec. Then it gets down to 9 plus 8. How can we see this? And it's just the same thing, looking at it in relationship to 10. Again, if I slide 1 over on the top to make 10, I'm going to slide 1 away on the bottom. And it's much easier to add 10 plus 7 than it is to add 9 plus 8. So that's kind of what the number strings will look like in your Fluency kits. So number strings are your opportunity to teach, but you still want the kids to engage in that discourse so that you can kind of hear their thinking, correct it, and you're not teaching a strategy that's too hard or one that they already know. Any other notice and wonders from the math talk there? Or the number string, sorry. And I do think sometimes if you look up math talks on the internet, you will see them talking about really talking about number strings when we're kind of differentiating here between 2 things. Also, if you notice the kids, she was throwing up some hand signals. I'm going to give you a visual that you can put in your classroom that you can use. This was kind of like, I have the same strategy. I've also seen people do like that, like this. I think the who else got it right and everybody kind of, or who else got 28 and everybody kind of did that. Yeah, she showed how that student strategies built on each other and they demonstrate the different ways to make the numbers, right? Um, and notice that there she was doing this. You're gonna have kids who are gonna pop that answer out because somebody in there is gonna know. I'm sure there was some kid in there that just knew 28, I just knew that, right? But you don't want them popping the answer out while the other kids are thinking. So Brittany says to have them do like this. But it seemed like this group of students knew when to wait and give the answer. And then this can also mean I have one I'm still thinking. This can mean I'm ready. I have one strategy. I have two. I have three. And I'll give you a visual that you can use if that's something you want to put in place in your classroom, because it's kind of a good way to look and see, well, okay, you have three. Who has three strategies? Who has one? Who may not have any? And a good chance for you to assess that. So I'm going to kind of take you through a number string. So in this number string, we're going to assume that we are, as students, we already know. And there's a resource I found with a ton of these on the internet. I'll show you that in a moment. I'll share that. I've shared that as well. But so this one is going to be, we know our sums to 10. We've gotten pretty good with using 10 frames and sums to 10, the rec and rec, so we know them. So you're going to ask your students, I went backwards. Sorry, I meant to go forward. Okay, 7 plus 3. Okay, so I know that all of you on here, we are all teachers. We would all answer 10, right? Okay, so that's when I would ask, how did you know it? Somebody may say, I know my numbers to 10. Okay, this is where I'm going to start asking you to put in the chat the answer to this and maybe how you found it. So if we know 7 plus 3 is 10, then we're going to go on. This is our helper problem. Number one's a helper. Okay, there's another problem. How can I find this answer? Drop it in the chat, and you can drop along your strategy with it as well. Okay, Marjorie. So 7 plus 3 is 10 plus 5 more. Yeah, it would fill one row on the top of the 10 frame. So what you're seeing, so if you were one of my students, I would say what you're seeing in your head, in your mind, and keep in mind one more thing to note, there can be some visuals during this, but there's no paper and pencil. So kids are working on mental fluency. So 10 is our benchmark number, and we're seeing that we know one 10 frame is full of 10. We have a row full, makes 15. 10 is also a benchmark number. So if I knew 7 plus 3 was 10, it's easy to add 7 plus 3. 10 plus 5, which gives me 15. This is also a great opportunity to say to your students, does it matter the order that I added? No, it doesn't. I can group the 7 and the 3 together and add the 5. That's just kind of early exposure to the commutative property. Next. Okay, who wants to answer this one? And kind of explain your strategy here. How do you get them away from just wanting to count dots on their fingers? I'm not, I think the idea is just continued practicing with this. You're still going to see counting on fingers and stuff, but I think it's just the more mental practice that you give them, the more that they're going to start to visualize a 10 frame, a number line, things like that. There's lights again. Marjorie, I like that. I like you did your 7 plus 3, which is your known fact to 10, plus 3 plus 3 more. So 13, and then you added on 3 more. So that is also a great strategy of using facts to 10 and decomposition. Okay. All right. This is our clunker. Okay. This is the one that's going to be the hardest. So this would be the last one that you would introduce in your number string. That's what Brittany calls the clunker problem. So can anyone think of a strategy to solve 9 plus 8? You don't have to base it on what you saw above. Some kids will, some kids won't. I like that. Jennifer took 1 away from 8 and made that a 10, then add 7. So she did some give and take. She took 1 away from the 8 to change the 9 to a 10. So that's give and take. And I think Marjorie did the same thing and add 10 plus 7. Somebody else may also decompose like 9 into 3 plus 6 plus 7 plus 1. You'll be really surprised at how your students are thinking. And then they say, well, I know that 3 plus that 7 is 10, and I still have that 6 plus 1, which is another 7, and that would give me 17. But you want to make sure you do what the lady did in the video, is honoring every kid's strategy. Even the little girl that was rather stumped, and the other little girl who answered 9 on that last one, she gave them the opportunity to kind of come up, model their thinking. And sometimes when kids start talking, they'll realize, oh, wait a minute. Yeah, I want to change my strategy, or I want to change my answer. And that's about you establishing that safe space where students can make those mistakes. And that I always like to say mistakes are expected and respected. Everybody's going to make them. So this is a format for the number strings, kind of your helper, your problem, and then your clunker. This one kind of had 2 problems. I think some of the samples, they may have 2 or 3 problems, but if you look at this one in the samples here, 9 plus 1, 9 plus 8, 3 plus 7. So they're kind of drawing on their knowledge of sums to 10, but then they throw in here the 6 plus 8, and they were using the Rec and Recs. When you go to assess with a math talk, there are no visuals. The students are kind of visualizing it themselves, and you're just kind of, these are some of the strategies that would come up. So there's get to 10, using known facts, counting on, those kinds of things. So we use the number strings to teach and the number talks to assess. Now, they said do 3 to 4 number talks. You might have heard her say within a week. I know we don't have a week, but do 3 to 4 number strings within a set, and then move on and do the math talk to to assess and see what your kids know. I was going to give you a moment to practice. We're going a little behind. I have linked in here. There are some hand signals and sentence stems. So if your students are, and I'll paste this in the link. Oh, that's not where I want to go. Okay. Let me share this. So these were some things that I got from a math professor at NCA&T when I was at the math conference. These were some of the hand signals that they used. So they talked about math talk, but they also demonstrated a number of strings. So that's where I noticed a difference. They did, I'm still thinking, I have a strategy, I have 2, I have 3, and I have 4. And then they just kind of shared their ideas of math talk strategies as well. I don't think that there is any one right or wrong way to do a math talk, but I think our Fluency kits do a really nice job of laying them out. If your kids are having trouble with finding the words, there are also some sentence stems that I attached to this that you might want to model. You model using them and then ask the student to repeat that back to me. So you can say, oh, okay, repeat this back to me. I broke the numbers into 3 and 7 to make it easier to add, or to 10 and 5. I use this strategy to help me add because. So these are just some good ways to kind of encourage them to the math talk. I know sometimes our students, well, nobody's first language is math, and our students sometimes struggle with finding the words. So practicing and modeling some sentence stems or having them kind of hanging up in your classroom can help the kids get with that opportunity to talk as well. Another thing that I shared on here were some, these are the Hands in Mind samples. Christina Tonable, freebies, I think I dropped that in the chat in her video. There is a free math summit on February 22nd, 23rd, I think. That's online. It is a weekend, but I think it's on their website. I thought this was pretty cool. I found this on a Twitter math site. But these were some ways to teach. This shows you kind of how to teach the strategy of making 10, use the strategy, and then they extend it a little bit more. Then we talked about making what we call landmark or benchmark friendly numbers. And then, they introduce using it here with 20, then using it here with 8, 5, and then they extend it down to going up to 100 and 200. So you can pick these up wherever your students are, the doubles and near doubles and all those things we teach our kids. So then there's the teaching to break it up into place value and using those as well. Some of these problems don't seem to be as related to each other, but I do like these where they do 16 plus 10. So what you would do is you would kind of, teach some of these, and then you introduce that one problem in your math talk that relates to that. So there's some pretty cool ones in here. I think they go all the way through. Yep, they go all the way through multiplication. Multiplication and division. So some great resources that we found. Of course, if you find anything, you are welcome to share it as well. If you are familiar with Graham Fletcher, gfletchy.com, he has got plenty of stuff out there on Fluency. And he does those, I forget what he calls them, but he shows like 2 buckets of 4 apples. And, how do you know that there are, and then he kind of extends it from there. So he does the kind of a slow reveal type thing with it on his website. So we will meet again on February 20th. I know that sounds like it's really far away, but I can't believe it's January 30th either. So in the chat, if you could drop just one thing that you, one takeaway that fits in any one of these categories from today before you go. And then after that will be your exit ticket today. So I would like to know what you plan to do, what you learned, if it didn't work for you, or a question that you may still have, just so that we can circle back to some of these in the future PLCs.